Good morning, students. Today we discuss different algorithms approach for concurrency control. In previous classes, we read the lock, different types of lock, binary lock, shared or exclusive lock, how we face the problem in consistency, and how we remove that things we already learned in the previous class. Now today's class we discuss the different algorithm approach for concurrency control. The first one is pessimistic approach and the second one is optimistic approach. The pessimistic approach causes transaction to be delayed in case they conflict with each other at the same time in the future. In pessimistic approach, the algorithm follows at first validate whether it will be conflict or not, after then read, compute and write. There are two common algorithm is used in pessimistic approach. One is two-phase locking protocol and another is timestamp ordering protocol. In optimistic approach, it is based on the assumption that conflicts of database operation are rare and that is better to let transaction run to completion and only check for conflict before they commit. And this approach follows this type: at first read, compute, then validate checking for confliction. After confliction checking, that will be the write. And there are some advantage and disadvantage of optimistic method. The advantages of the optimistic methods are: it is very efficient when conflicts are rare. Since conflicts are rare, at first we check all the transactions and checking at the last point of validation. That means concurrent process will go on. Second one is the rollback involves only the local copy of data. The database is not involved and thus there will not be any cascading rollbacks. Since in optimistic approach the rollback involves the local copy, since that will be not write completely, so the rollback is done in the local copy, that will not hamper with the database itself, and thus the cascading rollbacks problem will be removed. What is cascading rollbacks? We see in the another example later. Now, disadvantage of the optimistic method. Disadvantage means if conflicts are expensive to deal with, since the conflicting transaction must be rolled back. If in a transaction the conflicts occur, then there will be some problems. If more conflicts occurs, then more rollback will be there, and that will be the main problem in optimistic method. In longer transaction, we assume that there will be more conflicts. So in longer transaction, the optimistic method is not appropriate. Now we start with the first algorithm, two-phase locking protocol for pessimistic approach. In two-phase locking protocol, there are two specific phase. One is growing phase, another is sinking phase. What is growing phase? Growing phase means during which all locks are requested. In growing phase, we can give the lock for any items, and in sinking phase, during which all locks are released. That means in sinking phase, we unlock all the lock items. In two-phase locking protocol, there is no any situation occurs that there will be some lock, then unlock, then again lock. That situation is not occur. In two-phase locking protocol, at first all the transaction is in the growing phase. When the transaction growing phase is completed, that will be in the shrinking phase. That means release the lock. Now here we consider some example. In T1, at first lock, exclusive lock with the items B, then unlock B, exclusive lock with the items B, then unlock B, again exclusive lock with the items A, and then unlock A. So it will be not supported as the two-phase locking protocol. Why not? Because here this will be the growing phase, here this will be the shrinking phase. While shrinking phase is there, then you can't again start with the growing phase. So this will be not in two-phase locking protocol. Now for T2, here exclusive lock, that is the growing phase starting, again exclusive lock, that will be the growing phase. Okay, first case that will be the for item B, and the second case that will be the item A. Now this will be the shrinking phase, that is unlock B and shrinking phase. So at first that will be the growing phase, then shrinking phase. So this will be the support two-phase locking protocol. Now for T3 transaction, here shared lock is issued for the item A, that means growing phase. Here unlock A, that means shrinking phase. Again shared lock for the item B, so that will be again growing phase. So in this, that will be not possible. Growing, sinking, growing to sinking, again sinking to going is not possible. Again that will be the shrinking. So that does not support the two-phase locking protocol. Now for T4, here at first shared lock for item A, that is growing phase, shared lock for item B, that will be also growing phase. Then complete the growing phase, we start the shrinking phase, that is unlock A and then unlock B. So that will be support the two-phase locking protocol. Now we check the serializability in locking protocol. So how we check? Again we draw the precedence graph as earlier in the scheduling, that is conflict serializable. Now how the precedence graph is designed? All transactions are node and an arc, that is every transaction are in node, and an arc from Ti to Tj, that is Ti arrows Tj, if Oi of Ti and Oj of Tj satisfy the following condition. Oi means the locking scenario, that will be the Oi and Oj. What is the first condition? Oi and Oj operates on the same data. It must be on the same data. Oi is unlock and Oj is lock, and Oi precedes Oj. Now take an example. Here is an example of some transaction, concurrent transaction. Here will be three transactions, T1, T2 and T3. T1, T2 and T3. So we write T1, T2 and T3, three nodes. Now lock A, lock B, lock C. Then unlock B, lock B. So this is the condition satisfied, that is unlock of B item for T2 and lock of B item for T1. So we can write T2 arrow T1. So we gave a arc from T2 to T1 with the label B, that will be the item. Now here unlock A for T1 and lock A for T2. So we can write T1 arrow T2. So we give a arc from T1 to T2 with the label A, that will be the item A. Now here unlock C for T2, and for this unlock C for T2 and this lock C for T2. So sorry, T3, lock C for T3. So there is an arc from T2 to T3 with C. Here also unlock A for T2 and lock A for T3. So there is an arc from T2 to T3 with the label A. So this will be the precedence graph of this scheduling, concurrent scheduling or concurrent transaction. And now this graph has a loop. This graph has a loop. So this schedule is not serializable. Same as earlier, if the precedence graph has a loop, that concurrent scheduling is not a serializable schedule. Okay, and that will be some conflicts there. Now, a specific theorem. What is specific theorem? If all transactions obey the two-phase locking protocol, then all possible interleaved schedules are serializable. The previous example, whatever we seen, that this will be not follow the two-phase locking protocol. Why not? This will be the growing phase, this will be shrinking phase, again growing phase. So that will be not possible. Clear? Now, what is the theorem describe? If all transactions obey the two-phase locking protocol, then all possible interleaved schedules are serializable. That means if all transactions obey the two-phase locking protocol, then all the intermediate schedule must be serializable. How we prove? We prove by contradiction. That suppose that the schedule is not serializable. Since the schedule is not serializable, then precedence graph of the schedule contains cycle. If the schedule is not serializable, then we get the precedence graph as cycle. So we start the transaction like that, Ti1 from Ti2, then Ti3 dot 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 Tip, at last Ti1. Since this will be a circle. Now let's take some small example. Suppose T1 arrow, T2 arrow, T3 arrow, T1. Now how we define that two-phase locking protocol satisfied? Then some lock by Ti2 follows on unlock by Ti1 as defined in the precedence graph previously. That is, OI is unlock and OJ is lock. Y is OI for Ti transaction and OJ for Tj transaction. So therefore Ti2, some lock by Ti2 follows on unlock by Ti1. Similarly, some lock by Ti3 follows and unlock by Ti2. Similarly, dot dot dot, some lock by Ti1 follows by unlock by Tip, or a lock by Ti1 follows and unlock by Ti1. A lock by Ti1 follows and unlock by Ti1. This will disobey the property of two-phase locking protocol, that at first we complete the growing phase and then we move to the shrinking phase. Since we assume that that will be not is a serializable, and that will be the contradiction, we say that all the transaction in obey the two-phase locking protocol has interleaved the serializable schedule. Now, what are the problems occur during the two-phase locking protocol? In two-phase locking protocol, the first problem is deadlock. If we apply two-phase locking protocol, that doesn't mean that deadlock will be overcome. Now for an example, whatever we study in the last class, suppose this will be a two-phase locking protocol. Okay, what is the two-phase locking protocol? Here exclusive lock for item B by T1, that will be grant. Here shared lock for item A for T2, that will be also grant. Now shared lock for item B by T2, that will be wait, and these two are not there in two-phase locking, that will be written in the last. Now exclusive lock for item A. Now exclusive lock for item A, that will be also wait, as in T2 shared lock will for item A is there. So there will be a deadlock situation, and this will be waiting until one of the transaction is committed. So this problem will be there in two-phase locking protocol also. Now for another example, in this case this T2 and T4, in this case if we assume this T2 and T4 are in the concurrent, T2 support two-phase locking protocol, T4 also support two-phase locking protocol, okay, but there will be a deadlock. How deadlock? In T2 exclusive lock will be issued for the item B, and in T4 shared lock is issued for the item A, so that will be no problem. Now here for T4 shared lock for item B will be issued for T4, and that will be waiting since already exclusive lock is held by T2. Similarly, when T2 wants to issued the exclusive lock for item A, it will be hold as T4 already hold the shared lock for the item A, so that becomes a deadlock. Now we discuss the another problem occurs during two-phase locking protocol, that will be the cascading rollback. Now here is a situation that T5, T6, T7, these three transactions are performed concurrently. Okay, let us consider if T5 and these three transactions also satisfied the two-phase locking protocol also, since growing phase, shrinking phase, so support two-phase locking protocol, growing phase, shrinking phase, so two-phase locking protocol. Now this will be also the growing phase, okay, so supports the two-phase locking protocol. Now if T5 fails after read A by T6 and after read A by T7, that is if it will be roll back from this situation, what happened? T5 must be rolled back, that is whatever the modification is done by T5 in for item A, that will be discarded, and this discussion also roll back to the T6 and T7 also, because suppose for an example initially A value will be 100 and after write operation A will be 50, then T6 read the A, that will be the read 50 and it adds 50, so that will be 100. Now there will be A will be 100 in this case. Now T7 read the value A will be 100. Now it will be discarded. That means originally A will be 100. So this will be, if T6 read that value will be 100, and add 50, that will be 150. As well as T7 also read the value of A will be 150, but it reads 100 and here it will be 100. So the problem will be there, and all T7 and T6 are rollback, and this continuous rollback is known as cascading rollback. One is rollback that affect to another for the rollback, and that affect to another for the rollback, and this problem is known as cascading rollback. And due to two-phase locking protocol, this cascading rollback problem is there. Now, how we avoid the cascading rollback? There are two different techniques. One is strict two-phase locking protocol, another is rigorous two-phase locking protocol. Now, strict two-phase locking protocol suggests that the strict two-phase locking protocol requires that in addition to locking being two-phase, all exclusive mode locks taken by a transaction must be held until that transaction commits. This requirement ensures that any data written by an uncommitted transaction are locked in exclusive mode until the transaction commits, preventing any other transaction from reading the data. That means in strict two-phase locking protocol, what that will be the things, that if an exclusive mode lock is issued by a transaction for a specific item, then until it will be committed, it holds that lock. That means in previous example, what we do in the strict two-phase locking protocol, when exclusive lock is issued for the item A by T5, then this unlock will be not performed until it will be committed. That will be the main things. If unlock will be not there, then this exclusive lock for the item A is hold, as T5 already issued the exclusive lock for the item A. So for T6 this will be hold, and for T7 that will be also hold. So there will be no any cascading rollback. Now the rigorous two-phase locking protocol, it requires all locks to be held until the transaction commits. Now, what is the difference between strict two-phase locking protocol and rigorous two-phase locking protocol? In strict two-phase locking protocol, we just consider that if any exclusive lock will issued by a transaction, then that for a particular item, that lock will be hold until it will be committed. In rigorous two-phase locking protocol, if any lock will be to be held to be issued by any transaction, then this lock will be hold until the transaction commits. That means in rigorous two-phase locking protocol, the transactions should be serialized in order in which they commit. In most database system implement either strict two-phase locking protocol or rigorous two-phase locking protocol to avoid the cascading rollback or some points of deadlocks. Now there will be some problem. there will be some problem. If we defined the exclusive lock, then another transaction for the same item, that will be waiting, and this takes the longer time, and it occurs the delay. Now to remove this type, first we consider this example here, T8 and T9. What is the situation in T8? That read A1, then read A2, read AN up to, and at the last write A1. Now if T8 holds exclusive lock for A1, as it will be right after some future times, then T9 that needs the shared lock for the A1 and shared lock for the A2 to display the sum of A1 and A2, that will be hold. That means unnecessary, if we define the exclusive lock for this item A1, which is in future used for write operation, then T9 transaction is not performed, and that will be waiting and waiting until it completes the exclusive lock and release the item A1. Now if we change this scenario, if we at first we give the shared lock for the item A1, and when we need to write or modify that things, then we perform the exclusive lock for item A1, then T9 will be shared, again shared lock issued for the item A1. So this T8 and T9 will continue operate simultaneously, concurrently. So that means if we initially lock the A1 by shared lock and then change that lock to exclusive lock when it has to perform write operation, then T8 and T9 performs concurrently, and these things will be known as upgrading. Upgrading means upgrading can take place in only the growing phase, that is upgrading from shared lock to exclusive lock, and downgrading can take place in only the shrinking phase, that means from shared lock to from exclusive lock to shared lock, that will be the downgrading. Upgrading means from shared lock to exclusive lock, and downgrading means from exclusive lock to shared lock. Now if we write this previous example T8 and T9 in such a way that at first shared lock issued by A1 for T8, then shared lock issued for A1 by T9, since these two shared lock are compatible, so no problem. Again shared lock issued by T8 for A2, similarly shared lock issued for by T9 for A2, then all the shared lock issued by T8 for A3, A4 ... AN. Then after complete the T9 transaction, it will be unlock A1, unlock A2, that means release the shared lock of A1 items and A2 items. Then we can upgrade the shared lock of item A1 by T2 to exclusive lock to perform the write operation. Then these two operations T8 and T9 are operate concurrently. So For the time being, thank you.